privileged tonight to have a distinguished speaker who will be speaking on Iceberg REST catalogs. And at this moment, I'll hand it off to Alex.
Thank you, Joe. Hey, everybody. My name is Alex Merced, and always love joining all you guys here at the Tampa Bay Data Engineering Group for these meetups. And today I'm going to be talking about the Iceberg REST catalog, making catalog interoperability happen. So let's kind of go into it. But before we get started, I always like to kind of introduce like who I am, where I'm from, all this stuff. So again, my name is Alex. I'm a senior technical evangelist at Dremio. I've worked in the web and dev spaces all over the place and host a lot of podcasts. Probably most well known for being a co-author of Apache Iceberg: The Definitive Guide, a book that was released this summer by O'Reilly, which you can actually go get a free copy of by scanning this QR code here. You can get a free copy of Apache Iceberg: The Definitive Guide, the full book, as a PDF that you can read over to learn more about Apache Iceberg, the main topic of today's talk. And not only that, if you want to keep learning about Apache Iceberg, I'm also currently doing a ongoing Apache Iceberg crash course. We are now 5 sessions in, so we have 5 more to go. Those will continue running through October 29th. But when you register, you do get on-demand access to all the sessions that have already happened. So that's there. And then, again, for those who are watching this in the future, if all 10 sessions have already passed, you can still get access to all 10 on-demand sessions by scanning that QR code. So always a good time to scan that code. Again, I mentioned that I host a lot of podcasts. These are those podcasts. You can find them on iTunes or Spotify. So if you like listening to just random discussion about data and data topics and data modeling and data technologies and data trends, subscribe to these podcasts. You can find all those links at my website, alexmerced.com/data. That's where I put all the links to all my data content. And Gnarly Data Waves is specifically a podcast specifically from Dremio, where you have people come in and talk about data lakehouse topics. Which, on that topic, what is a data lakehouse, right? Because if we're talking about Apache Iceberg, well, then we're talking about the data lakehouse. And if we don't know what a data lakehouse is, well, that's going to make this whole topic a little hard to follow. So I always like to level set and talk about what is a data lakehouse. And to really understand what a data lakehouse is, we need to understand where we're coming from. In the sense that before data lakehouses were a thing, we would, and still for the most part, traditionally we use databases and data warehouses. And the beauty of databases and data warehouses is that they abstract a lot of things for us. Things that we just don't have to think about. When I use Postgres or MySQL or use Snowflake or Redshift, I'm not thinking about how the data is stored. Okay, I just write data, I insert into my tables, I update my tables, and the data is there. Okay, I'm not really thinking about how that is actually being physically manifested onto some disk somewhere. How does it know that that specific data is table A and this data over here is table B? I don't have to think about that. I just write my SQL. It works. It's good. And how does it know that I have all these tables like table A, table B, table C? It just knows. Again, and that's the catalog function. So again, all these sort of levels of abstraction of how you define a table, how do you catalog those tables, all these things are just sort of abstracted away from me. And then at the end, when I write my SQL, how do you parse that SQL, turn that into an execution plan, and then execute that execution plan? That's abstracted away from me. All as a sort of vertically integrated tool, whether we're talking about databases that store data typically as like row-based data to be more optimized for transactional workloads, while data warehouses oftentimes more in a columnar format for more analytical workloads. Whichever one, all this stuff is just kind of abstracted away. I just put in the data that I need, ask the questions that I want, and it works phenomenally. The problem is particularly on the analytical side, is just that the ways we need to use data are growing. The amount of data we're working with is growing. So it's becoming harder and harder to just use a data warehouse for this. Just because no data warehouse really has all the tools for every possible use case. And because of if it's bundled nature, no one else knows how to talk to that data but the data warehouse, because it's all within sort of its own storage format, its own table format, its own catalog that other systems don't know how to talk to, which can also get really expensive. So wouldn't it be nice if I could, instead of having to like make copies of data into different systems, which also creates a consistency issue because, hey, every system has its own way of doing things, so I have to make a separate copy of the data. Wouldn't it be nice if there was one place where I could store the data and multiple tools can access it? We do have that already. We generally call that a data lake. And essentially, really all a data lake is a distributed storage system. The idea is just that, hey, how about we store our data as files, and we can just access it, whether it's structured data in like a Parquet file, or it's in a CSV or JSON file, or unstructured data like audio files, MP3 files, video files, whatever. All that can just go into the storage. And then for the structured data, like those Parquet files, CSV, JSON files, I can use tools like Dremio or Athena to query that data, and that works. And generally for like read-only purposes, up to a point, it works well. But as the data sets get bigger, it's harder and harder to really kind of get the performance out here. Here, you can't really like do a lot of updates in a very safe way. It still was lacking a lot of the abstractions that made databases and data warehouses work. So this is where we have the data lakehouse. We take that storage layer. So this could be your S3 or Azure ADLS. On-prem, it could be something like a MinIO or Vast Data. Okay, and I say on-prem, I say on-premises. So we'll take that storage. We'll take those existing compute tools like Dremio, where I work, Athena, which is a compute tool from AWS. We can still use those tools, but now what we're going to do is we're going to inject a couple of those missing layers. We're going to inject a table format. This is where Apache Iceberg comes in giving us a way to not look at the data as a bunch of CSV, JSON, and Parquet files, but look at the data as table A, table C, in the same way that I look at it with a database. So essentially allow my data lake to operate more like a data warehouse. And a catalog, which could be something like a Nessie or a Polaris, that basically keeps track of all those tables, so that way we know which tables exist. And now I can truly really interact with my data lake as if it were a data warehouse. So thus my data lake has become a data warehouse, thus the term data lake house. Okay, so the idea is we're just filling in those gaps, and instead of having this big bundled system, we have all these pieces separately implemented, and then we can swap out whichever versions you want. So essentially it's a deconstructed data warehouse at the end of the day. But as I mentioned, the table format is Apache Iceberg. And Apache Iceberg, the way it works is by providing us a bunch of metadata that allows us to identify what a table is. So you would have a catalog, okay, which is going to be a big topic for this particular presentation. But right now, just know that the catalog tells me which tables exist. So I know table A, table B, table C. And that catalog would then point us to where the newest metadata for that Iceberg table is. And that Iceberg metadata would break up into 3 layers of metadata. Now again, for me to use Iceberg tables, I don't need to know how any of this metadata works. The beauty of it is, when tools like Dremio implement the Iceberg standard, the end result for you, the end user, is that your experience is that when you're using Dremio connected to your data lake, it works like as if you were connected to Snowflake or Redshift directly into their internal storage. Okay, basically works like a data warehouse, but you're really using your data lake. And that's the beauty of it, because you get that data lake price point, you get that data lake flexibility, and you don't have to make as many copies of the data, but you get that sort of ease of use, that SQL functionality that you would expect in a data warehouse. But you get these 3 layers of metadata. The first is the metadata.json that tells you what the table schema is, how the table is partitioned, all these different stats about the table. And that would generally point you to a particular snapshot or a particular version of the table, usually the newest version of the table. And each version of the table gets a manifest list, which is a list of manifests. Kind of a mouthful there. But essentially what the manifest list tells you that, hey, there's all these manifests, which each manifest is a group of files that make up the table. So how do I know that these 1,000 Parquet files are the current version of the table? It's because the manifest list will tell me which manifests list the files that are part of the table. And then using that, that'll get me to the different manifests that each have a list of files that are part of the table. And then from there, I can now read the data files. Like now I know which Parquet files are part of the table, and I can read them. And this gives and again, all of this provides a bunch of statistics on all of these. Like the manifest list has statistics on manifests, and the manifest has statistics on data files that allow a tool like Dremio to sit there and determine, hey, out of these 1,000 files that are this table, do I really need to scan all 1,000 files? Maybe this query would be fine just scanning 30 of them. And that's how you're able to get like data warehouse-like performance on your data lake. Because Iceberg does not only allow you to define the table, but the metadata acts like an index on the table, allowing you for very fast usage of the table. But again, that key arbiter of what's the table is this whole catalog thing, and that's what we want to focus on today. Because Iceberg truly needs a catalog for it to really work, to maintain those asset guarantees. Because what happens is that there's a bunch of files sitting in your storage when you use an Iceberg table. Just to go back for a second, there's like this, every time you change a table, you create a new metadata.json. So you see here like v1, v2. So if you've made 1,000 changes to this table, you could have like v1000, v1001, metadata.json. So we need something to tell you, hey, which is the newest one? You may be thinking, well, it's the one with the highest number. But that's not always the way these files are named. Okay, some tools, when they create that metadata.json, may give it like a, it'll be like a hash of the timestamp. So it'll be like a bunch of numbers dot metadata.json. You don't know. So there has to be a way to know, hey, this is the correct metadata.json to use right now. There has to be an arbiter of what is the current truth of the table. And that's the role of the catalog. Okay, the catalog acts kind of like a phone book, right? When I go to a phone book, I can look up like Bob's name and then find his phone number. And I know, hey, that's Bob's phone number. I can call Bob at that number. In this case, when I use a catalog, my query tools like Dremio, Snowflake, Apache Spark, Flink, they can communicate with different catalogs, which you can see represented here in this catalog bucket, and then they can discover the tables that are sitting on my data lake storage. And the way they do this is that when they communicate with the catalog always knows, hey, this particular table belongs to this metadata.json. And at the end of each transaction, that's when you update the catalog. So the catalog only gets updated if the transaction is complete, and that's how you get the ACID guarantees or the atomicity in Iceberg, right? Because, hey, what if we only halfway did this transaction and it failed? Well, then the catalog would have never been updated, so no one's ever going to see that half-done job. Okay, so the catalog becomes really, really important in the way Iceberg works, okay, more so than any of the other table formats. So having this thing that just tells you, hey, this table, newest thing here, this table, newest thing there. It's just pointing to you where to find that metadata on your storage. Now there's two ways this catalog can work. There's a file system catalog, okay, which is the easiest or simplest catalog, but it's also discouraged for production use cases. So this is also oftentimes referred to in the documentation as Hadoop catalog. It doesn't have to be for Hadoop. Like Hadoop is just one storage system. You can use Hadoop catalog for S3, Azure, doesn't matter what the storage layer is. But it just means, what it's trying to say is that this catalog leverages the file system. And the way it does that is that instead of having like this server, this service that runs and that you would make requests to, you just store the reference in a file called version hint.txt. So what happens at Dremio, it would go access that file. You would just kind of assume that this folder is where the table is. And then inside that folder, there's a version hint.txt. So Dremio would then go read that file. And in that file would have a reference to which is the right metadata.json. Okay. Now this is fine. The problem is you have to update that file. Every time the table changes, that file has to be updated. And distributed storage systems don't always have the same exact guarantees when you update a file in that storage system, okay? Because again, these files have to be replicated across multiple nodes. It's not as simple as just like, hey, a file on my hard drive. So in that case, for some systems, there is no guarantee that if two people try to update that version hint.txt, that you're going to get the right result. So you can, when you have multiple writers, there's a potential for inconsistency. Okay, so generally this is an easy way to use Iceberg, an easy way to get started and try it out. But for production, especially when you have multiple writers or multiple writes happening concurrently, this is generally discouraged and not recommended, but it is a thing. Generally, most people's first use of Iceberg is going to be using Hadoop catalog because it's going to be the easiest way to kind of get started. So generally what's preferred and what's recommended for production is you have some sort of service catalog, okay? And that generally is going to be one of these right here. So you see like Dremio has its own built-in catalog. There's Nessie. Snowflake has a built-in catalog, but there's also open source Polaris, which I have the logo I haven't added to this presentation yet. AWS Glue, Hadoop, Hive specifically can be used as a catalog. Tabular, although you can't sign up for a new Tabular account anymore. So, I mean, you have lots of options. And there's even more than this. So what these are is they're running services. So this would be like a piece of software that you would be running. So you'd have to set up like a compute instance to run this catalog software, unless it's being managed by someone else. But the beauty of it is that since it's a piece of software that's independent of the storage system, you're not reliant on the storage system's guarantees to guarantee that you have a consistent definition of the table. So usually what the way these services work is that they use some sort of backing database. So it could be like a Postgres or a SQL or whatever. It doesn't matter what the database is. But there's a backing database storing these references, and then you can make a request to these. And the service itself will have some sort of built-in locking mechanism. So they can, hey, someone's already updating this table. You can't update this table. But they can also lean on the locking mechanisms of the backing store when they update those references to make sure that two people can't update the same reference at the same time. Okay, so you're going to get much better consistency when you're using one of these service catalogs versus using the Hadoop catalog or the file system catalog. Okay, cool. So basically, like recap, Iceberg is a table format. It allows us to say, hey, this group of files is one table. But we need a way to discover those tables, so we have catalogs that allow us to kind of tell which tables exist and find out where the metadata is. But the problem was a lot of things. And those problems are what led to the development of this Iceberg REST catalog specification. So before we get too deep into what REST catalog is, let's first get into what the problem it is solving. So the problem before is that, let's say you wanted to create a catalog. So for example, Dremio developed this open source project called Nessie. That was a catalog. And the way you would do that is that you would have to create a client. So basically what would happen is that first you have to create the server. You have to create the actual catalog software. So the server. So the Nessie server software got created. And then you'd have to create a client library. And again, just to make sure that to level set, server just generally means like the thing that's running that takes requests. And then the client is the tool you use to make requests to that server. Okay. The same way that you have you have a waiter and then me sitting at a table, I'd be the client, and then the back end kitchen and the waiter would be the server. They're serving up my requests. But essentially what happened is that you would create the code that creates a server, the service, and then you'd have to create a client. And the client usually would be a Java class, because in the beginning of Iceberg, all of Iceberg was really in just one language, Java. Okay, because most data tools are written in Java. So you had Iceberg and all these supporting libraries, and then you would create a custom client class for that catalog. So each catalog had its own Java class. Wonderful, that worked fine. And then basically anywhere you use the Iceberg libraries, you can use that class and use that catalog. Okay, problem was not everyone wants to do everything in Java. Okay, so eventually they started adapting the Iceberg specification to other languages. So you have a Pi Iceberg, so Python Iceberg version now, a Rust Iceberg, Go Iceberg. So they're basically re-implementing those core Iceberg libraries, but they're not re-implementing every catalog class. So it's up to the builder of each catalog to then have to rebuild that client for each language. Okay, so there's our first problem. Okay, so if I'm a catalog company, every time there's a new language that Iceberg is in, now you have to create another implementation of that catalog. That's a lot of work. And then generally the way the client software worked is that it was up to the client. So when I use Spark as my client to talk to an Iceberg catalog, I would have to specify which library I'm using for my catalog. So what if I'm using an old version of the Nessie library because I don't know that there's a newer one? Well, that might cause inconsistent behavior. Okay, so there's two issues now. One, the fact that you have to kind of build all of these client classes. Two, that how do you know you're using the right version of the client class? And then three, when it came to managed tools, so like using a tool like Dremio or Upsolver, where basically, you're not in there writing custom Java code, they built the tool. Well, then it's up to Dremio to have to like add support for each catalog and have to then every time someone comes up with a new catalog and a new client class, Dremio would then have to add that as a separate connector. And that would go for all tools. So then what happens is that some tools would support some catalogs, some tools would support other catalogs. You had this really sort of fragmented catalog support. Okay, so basically the promise of Iceberg is to be able to kind of use your tables anywhere, but based on your catalog, you could only use your tables somewhere. So the solution was, how about we make it where, one, the server does more of the work, because the server generally, again, then the client doesn't have to worry about the version of their client because the server is doing all the work. Okay, one. Two, create a standard interface. So the idea is that, hey, let's create a standard way that that any catalog can talk to a server. So that way, it doesn't matter which catalog you're using, you can use the same client library. So that way, you don't have to build 10 client libraries for 10 different catalogs. Okay, and this just generally will make life easier. And that also means a tool like Dremio or Upsolver or any other ones don't have to create 10 connectors. They can just create one connector for that universal client library. And that is the Apache REST specification. So the Apache REST catalog is not a catalog. It is a standard interface. So the idea is that a server, so like Nessie has implemented the REST catalog. Polaris has implemented the REST catalog, and there's others, which I'll bring up in a little bit. But the idea is that if they basically set the server up that they can be communicated to using the specification, then any client library built to communicate using that specification can talk to it. So that means you only need one library in Java, one library in Python, one library in Rust, one library in Go instead of dozens. Okay? And now you don't have to worry about updating because the REST client doesn't really do much. It just sends requests. All the work is now done on the server. So long as so basically the version of how you do things is based on the server. Okay, so you don't have to worry about, client versioning. And again, now if you're a tool, a service, you can build a support for all catalogs by just supporting REST catalog. You create a REST catalog connector, and that should be able to connect to all catalogs because as long as they support this specification. So it alleviates a lot of the problems. Now keep in mind, this specification doesn't cover everything that a catalog can do. The specification is focusing on one thing only, the ability to work with Iceberg tables. So the specification is really just outlining all the different actions to read and write Iceberg tables. Okay? It doesn't deal with like catalog management. So like, hey, how do I manage my catalog? That's separate. Each catalog is different. But the thing is that I'm not going tool to tool to manage my catalog. So that part can be different. Okay? But the REST specification is a specification that creates a universal language for just talking about reading and writing to Iceberg tables. And a catalog does not have to implement every part of the spec. So these are all tools that support REST catalog to some extent. Okay, so you can see here, and these are not all of them. These are just many of them. So you see Dremio, Snowflake, Flink, Apache Spark, so on and so on and so on. So there's lots of tools that support this REST catalog, making it much easier to work with Iceberg because you can have one catalog and it can communicate with all these tools. And then you have these catalogs that support the REST catalog spec so far. So you have first you have Nessie, which is the one all the way to the I'm just going to start all the way to the left. So it's Nessie, Gravitino, Unity catalog, and Polaris catalog, which is actually now Apache Polaris, as it just became an incubating project. So it's not officially a Apache top level project yet, but it's on the next step towards that, which is pretty cool. And then Nessie and Polaris are both sort of really kind of open source options. Well, actually, all of these are technically open source catalogs that are currently available. But just to kind of emphasize that whole idea that just because a catalog exists doesn't mean it does everything the REST spec does. So while Polaris, Nessie, and for the most part Gravitino are complete implementations of the REST spec, Unity catalog only really implements the read part because Unity catalog is mainly more of a Delta Lake type catalog. And the reason it has, it exposes Iceberg, it has a feature called Uniform, where you can kind of create Iceberg metadata of your Delta Lake tables, and they can be read using that REST catalog specification, but you cannot write to them. Okay, because it would be tough to maintain consistency if you're writing to two formats. Okay, so again, just because a catalog supports the REST catalog doesn't necessarily mean it does everything the REST catalog covers. And then two, the REST catalog doesn't cover everything that needs to be done with that specific catalog. So for example, in Nessie and Polaris, there's a lot of different catalog. For Nessie, there's like a Git versioning thing, so like making branches, whatnot. That's not covered by the REST spec. In Polaris catalog, there's this whole catalog management for like RBAC, role-based access controls, where you can create roles, catalog roles, whatnot. That's not covered by the REST spec. Okay, Polaris has its own spec for how it makes calls to do that management. In the future, who knows? That might become the catalog management spec um, that becomes a standard for other catalogs, but that's still to be seen. Like the point is like the space is still evolving in some ways, but it's a lot better than it used to be. I can now pretty much choose any of these catalogs and pretty much be able to take the tables, the Iceberg tables that I have in them, and use them pretty much anywhere. Like there's still other imperfections. Like again, there's like where's the data stored. So just because I have a catalog that X tool can read, I might have the data stored somewhere that particular tool can access, but we're getting much closer there. Now, to really kind of see this in action, the best thing you can do is get hands on. So, for example, these are all different end-to-end data engineering exercises that you can do that get you hands-on with Apache Iceberg. That you can do right there from your laptop. So no infrastructure required, no cloud, just everything's done right from your laptop. The easiest exercise is all the way on the left. That's your intro to Iceberg exercise. And then the other three are sort of like end-to-end exercises where you start off with a data in a database of some sort. And then you're to ingest that into Iceberg and then build a dashboard off of it. So if you want to get hands-on with Iceberg, these are all great exercises to do. Also, I am been running this Data Lakehouse Hub. So this is a Slack community that you can join. I travel a lot to speak at a lot of different events. So if you want to find out about the events that I'm speaking at and network with a lot of other people in your local community, you can join the Data Lakehouse Hub Slack channel and then join one of the Slack channels, one of the channels in that workspace for your local area. So depending on where you're located, and you can meet other people there, find out about events that I'm speaking at. You can just scan that QR code to join the Data Lakehouse Hub. Also, we do have a Luma calendar where also every event that I'm speaking at will be listed. So you can subscribe to this calendar and always kind of know when I'm going to be speaking at what event, on what topic, where physically. Like I know I'll be in Denver, Santa Clara, probably in Europe. I'm still working those details out, and Las Vegas between now and the end of the year. So, yeah. So basically at this point, we're kind of hitting the end of the presentation. What I am going to do is I'm going to go all the way to the back because there's a slide where you can scan to get the slide deck if you want to download it. So I'm going to show you that QR code and I'll start taking questions. So if you want to get the slide deck, you can scan that QR code. But with that, I will open it up to any questions. Feel free to type them in the chat and we'll see how that goes. Let's take a look.
They should be typing in the Q&A. I don't see any questions yet, but we can also add them as contributors if you want. You just right click on and add as contributor. They can speak if they would like to speak.
Oh yeah, I mean I'll just see if anything pops up in the chat or the Q&A first. We'll give it a minute, and if not, then we'll just call it a day. And then again, if you're out there watching this post fact on YouTube, you can also leave questions in the comments, and I should be able to answer them pretty promptly. But with that, this was as always, a fun conversation with the Tampa Bay Data Engineering Group. And thank you as always. And I will